It's a great pleasure to be here today. We've had some interesting conversations already during this week, and I hope that we can continue that. And I'll give a little bit of an introduction as to how quantum can impact this very important topic of island resilience. So myself, I'm a scientist. I'm from Europe now, but I'm an ex-European. I'm from the UK. I spent my early part of my career, 20 years, running large R&D projects to develop chemicals which could impact, future of semiconductor materials, displays, solar panels, and things like this. So we were creating physics through chemistry, and a lot of that was to do with how you do computational, how you use computers to simulate these molecules and to save time in the lab and make innovation more efficient. But today we're here to talk about a little bit about how 55 North is developing some of the solutions in the quantum space. I'm going to talk a little bit about quantum, but not too much, because I think it's more important that we focus on how can quantum impact some of the challenges that are being faced in the front lines. And then we're going to have a little bit of a roundtable discussion, which if anybody has any questions, you can hold those, and we might have a chance to answer them in a short time. So I think we'll start this brief introduction by saying that the island nations face really, they're in a lot of pressure, a lot of vulnerabilities from climate, which is kind of a little bit outside of the control, and it impacted globally. Cyber threats, supply chain fragility, a lot of imports, and also this economic dependency. The technologies that are adopted over the next decade will have a huge impact on that. And we heard about how AI and blockchain can influence that. And I think quantum, being the next paradigm in computing, will also have a big impact there. Europe has this problem too, in a way. We lost the race of AI, right? This goes to the US and to Asia in terms of manufacturing and design. But in quantum, we still feel in Europe that we have a right to play and a right to win, because the game is different. The technology is still relatively early. We're generating a lot of IP and a lot of innovation. But there are some gaps still. The technology is being developed there, but the applications are also outside of Europe. And I think a lot of these applications can be really developed in the island nations. And they have there's a bit more of an impetus to do these proof of concepts and to develop solutions which use quantum technology and can really make a massive difference. And then the solutions can then be exported globally to create value elsewhere. And I think we can talk a little bit about that later on. So as Matt kindly introduced us, we're the world's largest dedicated quantum fund. We assembled, Matt called us, I left my underpants on the inside of my trousers, but Matt called us the Avengers. Myself excluded, that, I think that's not a bad way of describing us. My partners are Kai, who's here today with me. He was one of the first engineers at IonQ. IonQ is a listed company worth between 20 and $30 billion, one of the forefront leaders in quantum technology. And Kai has the most patents from anybody in IonQ and has developed a lot of their initial systems. So he really understands, I call him a physicist with a screwdriver. He really understands how to build these systems. My other partner, Helmut Katzgraber, is a theoretical physicist. He's been working on the maths that underpins all of this technology, benchmarking systems. He worked at Amazon and at Microsoft to develop their platforms. And he has now joined us in Copenhagen too. And the three of us together, with my experience on the chemistry side, Kai's experience on the system side, and Helmut's on the theoretical side, are really helping to work with some of the academics and the geeks in the industry and try and build some valuable technologies which can apply to real-world problems, whether that be on the computing, sensing, or on communications. And there's a big wave of technology which is maturing very rapidly. And to the earlier point of this being still like an R&D project, we're now seeing these technologies being translated into real commercial applications. We're seeing that it's about building supply chains, it's about building systems, and not just doing experiments anymore. We have a large number of companies which are going public. We have an awful lot of investment, over 20 billion of investment last year into private and public companies. And this means that we're now transitioning from a point of academic interest to real commercial value. And so it's a fantastic time to get involved and to try and see how we leverage these new technologies. So quantum is basically a new computing technology. It basically augments AI. AI can very well deal with data that you have already. It can very nicely interpolate between known data and to give you very quick and interesting solutions, as we see with large language models and other solutions. What quantum can do is augment those. It can do predictions outside of the space that you have data for, which means that you can open up new areas of computation that you couldn't do already. And it's definitely not a replacement to AI. It augments the technology. It goes hand in hand with AI. And the real drive at the minute is to build these systems bigger and faster, and more efficient. But it's not just about computing. There are these sensing applications, very mature technologies where you can get very, very precise sensing. And this plays now to how this can affect the islands on the front lines. Cybersecurity is one topic, right? Having data secure. If you're moving into a digital system, as we heard from the previous speaker, you want to make sure that data is secure and that you want your population to be comfortable to give their information and know that that's been dealt with in the most secure way. As well as your military and other assets that you have. And I think climate and resilience are two very important topics. Understanding how climate can affect you, and also understanding what resources you have. And this sovereign independence. We're dependent very much on satellites for communication and for navigation. And quantum, you can make systems which are decoupled from those systems. So you can have GPS style navigation without the use of satellites. And this can make independence. You can also maybe use these technologies to better understand and value what resources you have available. And I think these things are very important for how you price and value your raw materials, assets. And for example, if you're trying to do carbon credits, how do you actually demonstrate reliably and with confidence that these are real assets that can be sold? And quantum technology can have a big part in that. So, as I said, the market is increasing rapidly. We expect this to be it's about 2 billion in 2024. We expect this to grow to about 20 billion, at least by 2030. So we're at this transition point. So we're investing across this full stack: computers, sensing, communications. We're actively seeking, partners. And really the partners that we're looking for today, I think, are more on how do we actually find valuable use cases? How do we solve some of these biggest problems? We can compute new drugs, we can compute new materials for batteries, new materials for energy storage, or new ways of optimizing our supply chains. But I think there are so many other problems that island nations face, which could be addressed by this. And if we can start to bring some of these challenges to the surface, we can match that with the technology that we have available and see if there's some really interesting businesses that can be created, which can then be exported globally to the larger countries that maybe have not prioritized these particular projects. So I think, with that, I'll close for now. I think I've said most of the things I need to do to introduce it, and we can talk a little bit more in detail about some of the nuances there and go into a conversation about that. So thank you for your attention, and appreciate your questions and interest in what we're trying to do.
Hello, everybody. It's an honor to be here, and a very interesting topic we're going to talk a little bit further about. We've heard during just today about blockchain and AI, and if I think back about 5 years, this was something which was, when people said blockchain to me or AI, I would, yeah, of course, didn't know what it was all about. And I think that's where we are right now with quantum. And I think what we should try and do here is to get a better understanding of what quantum can do, but also what role can all of us play in the furtherance and proliferation of quantum and quantum technologies. So I would say my first question to you is quantum technology and the participation in the development of this only something for the biggest players we already know, or what can governments play? What role can a government have in the development of an own quantum strategy?
Yeah, I think it's a very good question, and I think it's something that we get asked a lot in Denmark. In comparison to a lot of the other nations that are prioritizing quantum, Denmark's a relatively small nation. But there are many layers to the implementation of a new technology. And it's not just about building the systems. You see China and the US investing, and Europe investing extreme amounts of money in this space. And that's to build the core technology. That's to build the next computers, the next industry that we need, the next manufacturing. And not everybody can be a part of that. But even that paradigm is different. So, I mean, Denmark has invested €1 billion over the last 5 years. And they've invested that in building the talent and the infrastructure in which to manufacture these quantum systems. Quantum is different to semiconductor in the sense that you don't need to build a $20 billion fab in order to manufacture it. Don't need to make these things on such a large scale. You just need to make them well. And I think having a focus and a strategy for everybody is important. I think if you don't have a quantum strategy, then you're missing the opportunity to be part of a disruptive new technology. And there are many new technologies that come in and go in the world, but truly, and this is something that we passionately believe as a team, and as a team of scientists, is that there's very few technologies which have the disruption potential at all levels that quantum offers. So we don't expect every country to be able to make these systems, but quantum computers and sensing will be available, and that will be an available technology to nations and I think it's about how you use that technology judiciously. So everybody uses AI, and everybody now is very familiar with it and is happy to invest in it. Very few people understand AI. Very few people understand how a GPU accelerates these workloads. And so I think it's about that transition between, the technology push and a market pull. And I think that's where, everybody can have a play. It's what problems do you have that we can solve with these technologies. As a chemist, I spent my entire career making chemicals, and you can cover the entire planet with data centers, and you cannot calculate chemical properties accurately. And there are many other things like that. So I think the island nations and on the front lines have huge challenges, which can be very, very difficult to address using current computational methods, but could be very easily solved by a combination of quantum sensing and quantum computing. And I think it's trying to identify what those challenges are and link them to the innovators that can provide those solutions, and then provide ways of doing proof of concept. So everybody can have a part of this technology.
Yeah. It's also, when you talked about the use cases, it's also about access, I think. Smaller nations can provide access for a use of a technology to find out whether this technology really works.
Yeah, indeed, and I think that's one of the things that we're very interested to explore. I think we see this a lot in dual use. I mean, obviously, Europe is on the front lines of a different challenge at the minute with Russia, etc. And that's had an incredible impact on the appetite for applying these technologies in a defense situation. But I think there are also many, many different applications in the environment which we haven't even considered and would not float to the top of the European priorities or the US priorities at the minute. And I think, having those access to those real challenges where there's real value creation and immediate benefit, I think could be really powerful.
Kai, you also spoke earlier about democratizing this technology, and maybe you could expand a little bit on what you mean by this.
Yeah, that's right. I think to play off what Owen said, there's an opportunity in quantum to leapfrog, right, the existing nations by being on the front lines, by being the deep subject matter experts at the problems you have that are potentially applicable across a broad swath of society and to these larger countries, with new digital technologies, with quantum computing being cloud native, with these early technology companies trying to find product market fit, trying to find real applications. There's an opportunity to push ahead, to really be the spear point of applications, use cases, and so you can generate IP, you can generate real value that then can grow and move into these broader markets, because you have the big blue economy, the large oceans, the deep sea resources, the mineral resources, with a strategy, with a focus, with really prioritizing quantum. And this is what we see in Denmark, right? Denmark is a smaller country. It's not small compared to some of these island nations, but when you're trying to play on a global stage, you have to pick your battles, and collective action can go a long way.
Yeah. I also think something very interesting that you, Owen, mentioned is the fact that this is not a play where you need to be investing a huge amount of money, maybe.
No, I mean the investment's coming in terms of manufacturing and things like that from established countries. We can also leverage a lot of what's available in the semiconductor industry. The first wave of quantum computing companies, they were very capital intensive. They had to invest an awful lot because building these systems in a lab with highly trained people takes time, and it was science, right? There was real scientific risk whether this would work or not. I mean, this technology was postulated in the 50s, 60s. It's only now that we're starting to really get to the levels of accuracy that we can really exploit and understand. We're trying to find the needle in a haystack. That's what quantum does in a short explanation. But that's not where value is created in digital economy. You don't have to be owning a semiconductor manufacturing fab to build a SaaS business model that can, return quite a large value. And I think that's the kind of situation we're in now, is that the technology exists. You can leverage that manufacturing excellence from other places, but it's how you apply it. How do you create value from those technologies? Which I think is perhaps where we should focus this conversation more.
Yeah, and that's maybe also a better way of understanding how one can contribute in this, to understand that, for instance, 55th North, you are focusing on the infrastructure. So not necessarily, something which is quantum or considered quantum technology, but something which can support the development of quantum technologies.
Yeah, so we're trying to build a supply chain which can help to enable this industry and scale it. So it's taking it from these lab projects and R&D into engineering, manufacturing, and into scalable products. And that's one element of it, and that's where the European focus is, because Europe wants to have a big part of this. Back in the 80s, Europe had 35% of the semiconductor industry revenue. It's now 6%. And they don't want to make that same mistake twice. They want to be able to have technology which has been developed and contributes to this. But for us, the biggest challenge is venture, and from a venture point of view, is always product market fit. And underneath, on top of that infrastructure underlying it, you have the computers and the sensors themselves. But above that, it's the same with the semiconductor industry. You make a lot of money selling computers, but the digital economy and the SaaS business models and the value that you create on top of those machines is where the real opportunity lies. Yeah. And I think that's the bit that we struggle most as a venture group when we're talking with academics who've developed this fantastic algorithm or this fantastic sensor technology, and they just don't know what to do with it. And if we can provide access to understanding what can I do with this, or what are the problems that I want to solve, people will figure it out. And it's a little bit like Arai said earlier around blockchain. We don't know what we can do until we have these things. But if we know what the real problems are, and if somebody's willing to pull on it, then it creates an impetus for people to develop solutions. And it doesn't cost a lot of money to sit down and say what your problems are. Right? And it doesn't cost a lot of money to let somebody run a test of a new sensor technology or a new algorithm, to try and see whether we can get data that supports that. So I think that's where the opportunity space is, and it's very untapped at the minute, I would say.
Yes. Looking a little bit forward, what do you think will be decisive for the positive and fast development of quantum technology? So what is required in order to accelerate from where we are right now?
I'm going to let Kai answer that one.
Well, I think a lot of what we see in the supply chain, at least on the quantum sensing side, is a lack of product market fit. We have a lot of technology pushing. There's a lot of mature technologies that aren't that expensive, but lack the solid use cases. And this is where I think the connection and the interconnectedness come in. Conversations like this, where we're speaking with the leaders of these nations that have problems but aren't currently part of the quantum conversation, now have the opportunity to really find, to provide value and capture value through figuring out, being clever and using their subject matter expertise to solve problems in new ways and think outside the box. And so there is a global arms race for these large data center-sized quantum machines, but there's so many layers underneath that. As Owen said, there's layers on top in the use cases for the compute side, and through cloud access, through digital technologies. There's room to play in that space, but there's also room to play in next generation exploration, mineral exploration, resilience modeling and measuring the environment, climate change, ocean levels, acidification, biomass monitoring in the oceans for fisheries and other types of things, right? There are these broadly applicable problems that, might get lost in the high level thing where people can come in and really figure out something new and capture value.
So really the answer seems to be that we all need to get involved, governments and capital and technical side.
Yeah, and I think it's not a question of we all need to get involved, but it's also a case of like, how do we, if people had acknowledged the value that AI could bring, 10 years before AI came, there would have been a lot more impetus on trying to figure out how to be a part of that. I think with quantum, we're at a stage where, it's still not too late. It's almost becoming an inevitability that this technology will come. And so now is the right time to think, how do we benefit from that, and how do we contribute to being a part of that future? In the same way that many other technologies have kind of leapfrogged, going straight to mobile phones over landlines, this kind of thing. I think island nations have a very different drive, a very different impetus, and it's a good time now, even to have the conversation. I think is a good time, and I think it will create value inevitably.
Well, thank you. I think on that we will conclude. So thank you very much for letting us into your world on quantum.
Thank you.
Thank you for having us.